An operator hits cycle start on a proven program. The tool plunges past the part, into the vise, and turns $600 of aluminum into chips. The program was fine. The mode wasn't. The culprit is one of the most basic G codes in the book, G90 versus G91, absolute versus incremental. And the way most controls handle the switch is exactly what makes it dangerous. G90 means absolute positioning. Every coordinate you write is measured from part 0. X 2.0 means go to the point 2 inches from 0, no matter where the tool currently is. Picture part 0 in the corner of your stock. Under G90, every move is a destination on that map. The tool doesn't care where it was, it cares where it's going. G91 flips that. Incremental positioning. Now every coordinate is a distance from wherever the tool currently sits. X 2.0 means move 2 inches further in X. From here, same numbers, totally different result. Under G91, X 2.0 from one starting point puts you here. From another starting point, it puts you somewhere completely different. Both modes are useful. Absolute is the default for a reason. It's predictable, readable, and easy to debug. Incremental shines for repeated patterns, bolt holes, engraved arrays, anything where the spacing matters more than the location. Here's where it goes wrong. G90 and G91 are modal. That means once you set one, it stays active until something else changes it. The control will happily run an entire program in whichever mode it was last left in. Modal means sticky, and sticky means dangerous when nobody resets it. The classic trap is a subprogram. You call a canned routine, maybe a probing cycle, maybe an engraving macro, and that subprogram switches to G91 to do its work. If it doesn't switch back before returning, your main program keeps running in incremental mode. Watch what happens. Main program is in G90. It calls a subprogram that switches to G91 for some pattern moves. Subprogram ends, returns to main, but the mode flag is still G91. The next absolute-looking line is now interpreted as a distance. Most shops blame the operator when this happens. The real culprit is a programming habit, subprograms that don't restore modal state on exit. A well-written subprogram saves the mode it entered with and puts it back before returning. The habit that prevents it is one line. At every safe restart point, tool change, new operation, top of program, write G90 explicitly. It costs nothing. It guarantees the mode you think you're in. Some programmers go further and stack the safe line. G90, G94, G17, G40, G80, every modal default they want enforced, written out at every restart. It looks redundant. Redundant is the point. Before you hit cycle start, look at the modal state page on your control. Every Fanuc, Haas, Siemens, and Mazak shows it. It lists every modal G code currently active. If it says G91 and you didn't put it there, if the modal page says G91 and you didn't put it there, stop. Don't single block past it. Dry running the program in single block with the rapid override at 0 will reveal the leak before the tool ever touches stock. It costs you 2 minutes. The scrap part costs you the whole shift. G90 is the safer default for a reason. Every line reads as a destination, so a bug is visible on paper. G91 hides bugs because the same number means different things depending on history. Use incremental when you need it. Reset to absolute the moment you're done. If you've made it this far, you already know more about modal state than most operators get taught on day one. The whole trick is write G90 explicitly at every restart. Read the modal page before cycle start, and treat any unexpected G91 as a hard stop. Subscribe for more plain English shop floor explainers.